All right, everyone. Welcome to Community Development's Learning Lab. Our presentation today is the 2021 Washington State Residential Energy Code on residential submittal applications, presented by Senior Plans Examiner Gerard Ravel. Please put your phones on silent, save your questions until the end, and when we'll have a Q&A session. CVTV is recording this Learning Lab, and it will be available on CVTV and on our website.
Good morning, everyone. I'm here today to talk to you kind of about the fun aspect of the energy code and as it relates to residential buildings. So with the Washington State Energy Code, or for the sake of this presentation, the WSEC, it primarily aims to reduce your carbon footprint. And in the process, it also helps to increase your comfort while likely reducing the long-term financial impact that utilities play in your life. Some of the key terms as we get started in this that will be helpful for your understanding and going forward with future projects are going to be dwelling, dwelling unit, accessory structure, guest house, building thermal envelope, and conditioned space. So to go over these in a little more detail, I put the code description of it and their definitions. We get these a lot of times in the building department, and so these are important for everyone's understanding when dealing with our departments throughout the county. So dwelling, it's going to be any building that contains one or two dwelling units. And what a dwelling unit is a single unit providing complete independent living facilities for one or more persons, including permanent provisions for living, sleeping, eating, cooking, and sanitation. Additionally, adult family homes, foster family care homes, and family daycare homes licensed by Washington State Department of Social and Health Services constitute dwelling units. Accessory structure, these are going to be structures that are accessory to, located on the same lot as, and incidental to the dwelling on it. Some examples of this that we commonly deal with in our day-to-day functions and from a lot of permits are detached shops, detached garages, detached guest houses, and offices, detached offices. One of the more common ones that comes up, especially with the current economy and how people are changing their existing spaces, is guest house. So a guest house is an accessory structure or building or portion of an existing building designed, constructed, and used for the purpose of providing temporary living accommodations for guests or members of the same family and containing no permanently installed cooking appliance. So that's a key aspect to that, how we envision this, separating this from what a lot of people view as a house or an accessory dwelling unit. So no permanently installed cooking appliance for guest houses. Building thermal envelope. So this is the below grade or above grade walls, floors, ceiling, roof, and other building element assemblies that provide the boundary between conditioned space and unconditioned space. Now, what's conditioned space? So this is going to be a space where a space that is enclosed within the building thermal envelope and is directly or indirectly heated or cooled on it. This is going to be probably the best example that I could find to illustrate the differences, or to illustrate thermal envelope, the building thermal envelope, and the conditioned space within. So here you have The red outline, kind of the shell of the building, sort of, if you will, or envelope. And everything outside, of course, that will be unconditioned. Everything inside will be construed as conditioned space. So the last, let's see, remodeling and altering conditioned spaces. So going to that conditioned space element here, we get a lot of projects across the county where people want to simply do an alteration or remodel to their existing house. They want to move some walls around or reallocate space for a bedroom, perhaps. This is, as far as the energy code is concerned, this is a fairly straightforward procedure. There's a form available, you see here, that we have access to from our webpage. And this allows you to it walks you through what are you doing with the scope of your project. So will you be exposing walls here? Yes, no. It walks you through what to do if that's a yes. The same thing goes for if you're exposing roof or ceiling, and so on and so forth. So if you just walk yourself through this, you'll find that this form more or less fills itself out for it. And this is going to be one of the forms that we at Clark County will look for when you're doing a project that's within your existing conditioned space for it. It will want this form filled out. You can access it. There's a link here, down here. You can click on that or go to that webpage and you can find this form directly there. As for the remainder of the residential, or the bulk, I should say, of the residential projects that come through Clark County, this is going to be a vital way to illustrate what the energy code expects for each of these projects. So as we went over, there are accessory structures. These are essentially detached structures from the primary residence. There are additions, and these are going to be ones that are attached to a primary residence that will be new square footage, that you're increasing the footprint of the building. And then there are new homes, of course, and new ADUs for it. And so you can go through this straightforward, if more or less, if it's an unconditioned space, one of the key takeaways from this flow chart is unconditioned spaces are exempt more or less from the energy code because you're not using energy in theory to make the space more habitable on that. It's whatever the outside environment is, more or less. Anytime you work to condition a space or to heat or cool it, that is where you're going to deal with the energy code. The Washington State Energy Code's minimum requirements fall into play for all aspects of conditioned spaces on that. When you have an accessory structure that is detached, of course, from the primary residence, even if you comply with the minimum energy code, you do not need what they call energy credits, or how are you going above and beyond the minimum energy code. If you have an addition, if you have a very small addition, as shown here, so being less than 150 square feet, okay, and this is, you're still complying with the Washington State Energy Code's minimum requirements. But if it's less than 150 square feet, you do not need to show any extra credits for it or any energy credits. If an addition is 150 square feet or larger, then just as a new home or an ADU, it's not enough to show just how you are complying with the minimum standards, but how you then need to provide the county or the jurisdiction with how the energy credits that you will need to show you going above and beyond. Okay, now let's breaking that down into two categories. So Washington State Energy Code, or WSEC minimum requirements. That's going to be a complex thing. So as we go through that and energy credits, hopefully this will become a little easier to understand. The differences between U value and R value. So this goes to the minimum energy code requirements for the county. There are what we kind of refer to as two paths to comply with that. There is a U value path and an R value path. And these terms, to a lot of people, are kind of opaque and can be confusing at times. So I want people to understand that these are merely an inverse function of each other. So they are a different language saying the same thing, is how I try and look at it on it. A U value is often used to show a more complete picture of your thermal envelope, of the building thermal envelope, whether you're talking about a wall, ceiling, floor, and an R value tends to be the smaller components within that envelope. So if you have a wall, an R value would be used to reference the material maybe that you put within that wall. But the U value is something that you use to reference the entirety of that wall from start to finish of it. The U value tends to be harder to understand without tools or programs for it. The R value is easier, so you can walk into a hardware store like Lowe's or Home Depot or something of that nature and ask for an insulation of R21, and they will likely have that for you to purchase and walk out of the store with. If you go in there and ask for, I need insulation that's U whatever number, they're not going to have that for you, because that's not how the individual components within the wall system, the ceiling system, the floor, how they're marketed to the public on that. So they both will discuss the same thing. They're just a different way of saying it. So you'll have R value being a common way to encounter it in the world, U value not so common. Within this, I try and show a visual to help understand a little bit more of what I was just mentioning, where this image up here, you have a U value path, and there are U value minimums for this path, of course, on that. And these reference entire assemblies. So for ceiling U factor, that would be every component within it. For the image over here, for that argument's sake, let's go to above grade wall. Okay, the U factor for that being 0.056. Now for our value path, we have wood frame walls. These two would be the same component here. And this image shows and helps illustrate that. You have a stud cavity with insulation. That will be one of those components that utilize an R value for people to help them understand. So you would go to, in the R value path, if you wanted to use this path, the wood frame walls, you would go R. This is always in R values, of course, for this table. So this would be R20 plus R5. And that R5, or R13, sorry, plus R10. What this really implies is this is going to be the interior insulation as that first number, okay, and exterior insulation as that second number, that R5 right here. This is a new aspect of the 2021 code versus 2018, which we'll get into in a moment. But these two components are part of the R value path for it. The U value path will weigh the entirety of this image as it. So it is more complex, certainly, but there is various advantages to doing that. It becomes where a tool will become almost necessary for it due to the level of detail and complications involved. And to get into that here, Washington State University has developed what they call a C3 calculator. It's a code compliance calculator, for those wondering. It's just 3 C's. So on their webpage, which have here at the bottom, if you follow this, it'll take you to this page. They have a clear link, or several links here, but rather I've highlighted a link that the path you would want to take to find this calculator to help you with your U values on it. The R value, of course, being something that you could go into the store and find pretty easily for them. If you follow this link here, will take you to another page, of course, here that's set up to help many different people, whether their project is a small 150 square foot project or 8,000 square foot dream home. They have a link here as shown. It's fairly small, but nonetheless a link that takes you to the C3 calculator requirements. In general, how they've set theirs up, you need a PC computer and access to Excel to run it. If you have all that, then you could follow their link down below to take you to the C3 calculator itself. On that, they have plenty of helpful links explaining how to use the C3 calculator, but it is an amazing tool that many at the county here use, and we get often for it. It allows, in general, users to pick the energy components that they want and to have an entire overview of their house, their efficiency for it broken down on it. So that's kind of a quick overview of the minimum energy code requirements for this. There is, like I mentioned, though, additional energy code credits that are required for a lot of different constructions that we have throughout the county. And in here, we have, at a glance, yes, it is quite a lot of information, but this is one of the more simple ways that we've found to illustrate all the options available to applicants when going through the additional credits. So it starts here, and this is going to be a form, by the way, that when we go to that spreadsheet that we had just a moment ago, where it talks about with new home constructions or ADUs, or larger additions being larger than 150 square feet. This is going to be a form that we need in Clark County, at least in our jurisdiction. We need this form submitted with your project for it to show how you're doing that. Up here, we do have this in the booklet or the pamphlet that was given out to you, but you could see this and you could zoom in at home if you're looking at this. It's a little small here, but you have the required credits based on the size of your project that you're working on, whether it's an addition, new home construction. It breaks it down here pretty easily as to how many credits you need. There are numerous categories for how you can obtain those credits, and it's one of the underlying things in this form is for these credit categories, you're typically constrained to one option within each category. There are some exceptions to this, but nonetheless, you're typically limited to one. How you go about your credits is more or less up to you. You can certainly ask questions at the county here or through other sources like at Washington State on this, but you kind of are given your path by filling this out on it. Now, there is a lot of information as stated here, and there's some circles that you might not be able to see on here that reference a slew of notes in this sort of middle column here. Now, this kind of goes into the specific code language of each one of these credits, but this is only something that you should really worry about looking at if the credit option you're interested in has a little circle with a number in there, then you could reference that in these notes. Otherwise, this is just here more of a, in case you need to know this extra information. The right-hand column here, this is going to be more for the plans examiners and the building inspectors for your project. This is going to be a collection of the information from the credits, as well as some of the HVAC components and maybe water heating components and other stuff of that nature. So one of the the categories that you could choose from here is going to be your heating system options. So how you're heating your system, how you're heating your house. Another one will be your building thermal envelope or your envelope improvements on it. Another one will be air leakage control. Let's see, air leakage control and efficient ventilation. Then you have high efficiency HVAC distribution system. Then a high efficiency HVAC category. An efficient water heating category. A renewable electric energy, and appliance package. So with these, one of these categories, the building improvement or envelope improvement category, these credits directly relate to how there's the minimum energy code requirements for insulation we briefly touched on, but this one will go into more detail about how much better you're going to go. So these will, if your wall was going to be R20 on the inside of that cavity and R5 on the outside, maybe one of these categories requires that to go to R12 on the outside or something of that nature. And that's where the right-hand margin here, I know it's formatted, so you kind of have to shift your head, but nonetheless, they have energy code minimums here along this column. And then below that, or I guess to the side, based on how you look at it, the intent here is that you would put whatever your project is requiring on it. So if you've selected a project that requires you to go above and beyond the energy code minimum for a wall, for example, then you would have to put that new information in this box where you have exterior walls, instead of leaving the code minimum on that. That's what the intent of this is. For the HVAC summary up here, this is getting more, of course, to the HVAC system that you have. If you know the cubic feet per minute, of course, that you're doing with your system, you would put that in here. There are forms that we also will have when you submit that will walk you through what size of furnace or heat pump that you'll be using, or system that you'll be using. And that's what the BTUs here, that's British Thermal Units, references kind of the size or the strength of your system. There's a category here that talks about the efficiency rating of your system. So whether your HVAC system, the term they use for it a lot is HSPF, that's going to be for your heat pumps. There is an AFUE for your natural gas systems on that. That's where you would put that number for it. There's an HRV as well, this category. So this is a heat recovery ventilator or ventilation. And this is a yes or no category referencing this air leakage control and efficient ventilation category, sorry. In this, they have a requirement for an HRV system, like we discussed there. And if you don't select this category, of course, then you could just simply mark no here. And if it has that, then you can mark, of course, yes. I might have flipped that around, but yeah. And then if you have information relating to the if you're using a gas furnace of some nature there, outside air, and then duct sizing as well here. Well, there is a new aspect to this table that has recently come into play. And then on November 5th of 2019, was it 24, the residents of Washington voted in to have an Initiative 2066, is what it is, voted into law, and it was enacted and went into effect on December 5th, I believe, roughly a month later. Then onto that. And what that aims at is how to more or less regulate the utility companies and various jurisdictions throughout the county and how they restrict the use of natural gas in most aspects of your day-to-day life. How it relates to the Washington State Energy Code is it has a mandate in the law where any jurisdiction, more or less, so any state agency, county, city agency, or jurisdiction in general, cannot discourage the use of natural gas in your, whether it's residence or addition or some kind there. In the past, the way the energy code was structured is it gave the potential for credits, extra credits on your for using natural gas, but not much. Compared to other paths, it was discouraged, more or less. And so Clark County has taken a stance where we have, this is hard to see on this form, I understand, but the current code, the way it's written, is this option in the heating system options for combustible fuels gives 0 credits. And we have decided to allow for temporarily, of course, while the State Building Code Council tries to rectify the code or change the code to accommodate this new law. In the interim, to comply with this, Clark County has decided to allow 1.5 credits for this option if you're using, for example, a gas furnace. Instead of 0 credits to start out with, now you can start out with a very similar or an arguably equivalent number if you were using a heat pump on it. So we feel that this is a great interim solution to get around or to at least comply with the intent of this law for it. We have, let's see. Sorry, technical difficulties. It's not allowing me to move. Oh.
Interesting. Oh. We'll keep going down. There.
Sorry about that. Fun with technical difficulties. Okay. So this kind of breaks down our solution a little better on that. Of course, that big form is even harder to read now, but we're going to focus more on our solution to that Initiative 2066. So with Clark County, what we ask, if you are going to, or if you're intending to use natural gas in some way to heat or condition your space for these projects, we have a new Washington State Energy Code, or WSEC, alternate materials, design, and methods of construction form to fill out. And I say that loosely because we have tried our best to make this as simple as humanly possible, where this form is more or less completely filled out with the exception of simply your permit number, your name, the project name, and that's about it for what you need for it. We just ask that this form be submitted at the time of submittal with the other submitted documents so that we can have this on file for it. So once you do this, then we could progress on with the energy code review for your project on it. You could find this form and that wonderful 11 by 17 form with all those credits posted on it at our webpage here shown. We've kind of showing you exactly where those links are. This new WSEC alternate materials design sheet or form is right underneath our 11 by 17 form with the credits. So you shouldn't have to go hunting for it if you do wish to use natural gas for your house or your addition on it. And then there is another highlighted area for a link to Washington State University's energy program for several other critical forms that we look for relating to the energy code, whether that's a glazing schedule or like a windows, what windows you'll have in your project, heating system sizing worksheet, which walks you through the kind of the thermal envelope, if you will. You have to identify the different insulation values that you'll have in your house, and that kind of gives you an approximate value for what size of furnace or heat pump that you'll be wanting for your project. And there are, of course, a couple other forms in there too, but that right there at the bottom is a good link for that right here. So probably one of the most important parts of this presentation would be what a lot of people are frustrated with on this energy code. So this is where the big differences between the 2018 code and the 2021 code come in. So we have two paths, as stated before, a U-value path and an R-value path. Well, let's look at the R-value path first. Well, this is mainly for that R-value path to keep things kind of simple. The energy code was structured, I guess, in a way where if you go down the R-value path without having to use that C3 calculator we mentioned briefly a little bit to go with the U-value, if you go with the R-value path, you have two ways to comply with the one big change that happened. And that is basically, do you want a more insulated exterior wall, or do you want a more insulated roof or ceiling? You could do, of course, both, which would be fantastic, but of course that comes at added expense. So usually you pick one or the other. And what that comes down to here is, do you want to keep your wall a traditional, for the area at least, a traditional construction practice where you have gyp on the interior of your wall for your house, you have your wood studs, you have your sheathing on the outside, and then your whatever kind of cladding you want, whether that's a lap siding or something. And in the inside of those studs, you have your insulation. That's traditional. And now in the 2021, one way to get around this new change is you can put what's shown here in blue, this being the inside of the house. This is a top view of the wall. This being the inside of the house, this being the outside. You have, of course, have your stud wall here with your insulation shown in that wave pattern and your sheathing. Now on the outside of the sheathing, you would have a 1 to 2 inch rigid foam insulation, kind of like the insulation you might find in a cooler. Kind of, that's what it comes in, these large sheets, typically 4 foot by 8 foot, that you could get just like sheathing at a lot of hardware stores for it. And of course, this adds cost to the project, but this is a very efficient way to add a dramatic amount of insulation without adding too much depth to your wall. There is depth, and this is why a lot of people have apprehension about using this approach to it versus the one I'll get into in a moment, because this is, of course, just something it's another layer of construction that they'll have to do for the project. But this is a very efficient way to insulate your house. The other path to get around this new change, so again, either a more insulated exterior wall or a more insulated roof. This one is diagramming the more insulated roof. So you have a traditional truss, kind of shown here on the left. A truss is going to be a roof member, of course, that holds up your roof system and your ceiling. But on the left here is a traditional truss, and right here, this is what we call the top plate. So it sits right on the top plate. This is usually only a few inches in height. Well, to get the added amount of insulation that the energy code now wants for it, you have to go to what they call a heel truss. So the truss has to be redesigned. This costs more money on it, of course, but it allows you to get the higher insulation value to the edge of your truss system. So this right here is shown as best as I could find here in this image, where it has increased the height of this truss. Now this has an exterior soffit, which brings air up through and in. Not all have this design, but nonetheless, this is showing this extra vertical height right here. So what I wanted to get at kind of here is using this is what the most common approach that we've seen for the county. But this is not wrong to do, of course. This is not wrong. Neither are right, neither are wrong. But the exterior wall, I would really encourage builders to look into the actual costs needed for it and the building practices needed for it, because this does yield usually far better return on investment for your energy efficiency on it. Like I said, they're neither are wrong, but I would recommend looking into this option more. We don't get this that often, but it is a nice choice when people select it. This kind of goes back to the U value table that we saw before, that the U value path. This one here, U value numbers are not something, like I mentioned, you can go into a hardware store and just ask, I want U 0.024 for my walls. Well, they'll kind of look at you goofy. But this is kind of referencing to that C3 calculator, which we really push as a great tool to use if you want to go that U value path. There's a lot of resources at Washington State's webpage for it. But if you do use it, these are going to be the common assemblies that we see, or the common insulation values within those components. So we have the attic, exterior walls, windows, and floor for these various components. And these being typical insulation values within for the specific components within it. The right-hand side here being the code minimum. And with U value versus R value, U value, smaller the number, the better. R value, the larger the number, the better, as if that's not confusing. So these numbers are often very tiny, less than 1. So the smaller this number gets compared to here, the better. So you don't want this number bigger than this number. So I've tried to show it in red, or a form of red here. That doesn't mean it can't work. It just means that it would require something in that C3 calculator to help offset it for values. So you can kind of pick and choose with that calculator what you want for it. On this, there is, let's see, wanted to go to this one here before we get too far into it, running low on time, I think. So with garage conversions, we get this probably, if not daily, close to daily for it. This is a very common practice for a wide array of reasons for it. And what people will ask all the time is, well, what do I have to do for a garage conversion? And this is, of course, relating to an addition for the house. So the garage is considered currently a garage before you could convert it. So that will be an unconditioned environment on it, which the energy code wasn't applying to it. But now you want to bring it into the habitable zone or the conditioned space of your house. So now that has to become part of the Washington State Energy Code. You have to meet those standards for it. So it's not just enough in a lot of cases to just say you're going to put up some walls and call it good. You have to show how you're insulating the floor for it, how you're going to be insulating the walls, how you, of course, insulate that new front to it where you have the garage doors, where you're filling in the wall. Of course, the attic as well, or the ceiling, how you're insulating that area. This whole garage has to come within the constraints of the energy code on it. And depending on the size, most garages being, of course, larger than 150 square feet, you would need to show also the what energy credits you're selecting for it. And let's see, with this too, there are what Clark County has wanted. This right here is the Southwest Washington Chapter ICC detail. And this is subject to change from time to time. They may update this in the near future, but as of when I made this presentation, of course, this was their current detail. With Clark County, what we also look for garage, we understand there's, of course, financial burdens for a lot of different reasons, but for a garage that is under 400 square feet, it's 400 or under 400 square feet, we don't require radon mitigation for it. It is encouraged still, nonetheless, but for smaller garages, we don't want to impose an excessive financial burden for such a small addition. When it becomes over 400 square feet, I believe, roughly a 20 foot by most garages will qualify for this, though, because if you have a two car garage, you're looking at 20 by 20 at least. So when you're over 400 square feet, we do require radon mitigation still. Radon being, of course, potentially cancer-causing, odorless, colorless gas that you can't really see. So kind of important on that. That note is not very well identified here. They have it on Southwest Washington Chapter ICC. They have up here talking about Appendix F in the code for radon gas. But nonetheless, this detail, if you are doing a garage conversion and you submit a detail from the Southwest Washington Chapter of ICC, following their web link right here for it, this should be enough for most of the documentation, not necessarily all, but most of the construction documents we would need for your garage conversion. There's not, obviously the garage is existing, so we don't need too much else for it. This will give the inspector and you, the builder or the homeowner or the applicant, the information you need to build it, or to at least bring it into compliance. So to wrap up, the Washington State Energy Code, it's not simple. It is complex. I could talk about it for hours and hours, and you would be bored and wanting to turn it off or walk out or whatever. I understand. But it is important to note that though when building a house or a new project, if you're going to construct one, it's easy to overlook the energy code because you experience the house physically in the built environment. You walk into it and you don't look at the interior of the walls. You don't look at the above the ceiling or under the floors. You don't see that stuff. So it's easy to dismiss the importance of it. In terms of getting the permits for it and in terms of your comfort, it is very important. I can't stress this enough, how much needless delay we have at the county for a wide array of problems with it, but mainly people not knowing what to submit or not knowing how to show us what they're going to be doing for the energy code compliance on it. This is an aspect that you cannot get approval for on most new construction and whatnot without complying with the code. So we get sometimes week-long delays or longer than that, where people say like, "Well, it's just insulation. Who cares, right? Like, come on, I need to start building." Well, this is according to the state, and for your comfort, it is something that is worthwhile to look at and to plan in advance when doing your project for it. So there are a couple different resources here. I'd like to point out again, as I've mentioned, the Washington State Energy Program. They have a very sophisticated website there and a great team, as does Clark County here for it. But if you have any kind of in-depth, really complex questions, they have Washington State is a great source for that first and foremost. Clark County, we're happy to help you as best we can with your questions. We have a great team here for it too. If it's, like I said, though, if it's a real in-depth question, probably be best fitted to ask Washington State University's team first, and then you could come to us. But we have their link right here on the page, and we have our email address here for, I think, our general line for questions and comments there, and it'll be directed to the right person or team to answer your questions for energy code purposes. All right. Thank you very much. And comments or questions?
All right, thank you. This is the Q&A session. To use the mic in front of you, you're going to press this button here. Please use the mic so that everyone in the room can hear you, and it will be picked up in the recording. When you press the button, light will turn green. When you are done asking your question, press the button again. The light will be red.
Yeah.
Is the 400 square foot radon mitigation only for garage conversions, or is that for any addition?
Excuse me. No, that is for any conditioned space or any habitable space that meets that in general, that 400 number I gave you, that was specific to garages that are all that exist, that you're converting to habitable space or conditioned space for your house, maybe like a new bedroom or rec room or whatever of that nature. That's where that number, that 400, comes from. Typically for all new homes or additions attached to new homes, any space that you're going to be living in, really. That's where radon mitigation is, in this area, required for it. All right. Yes?
Okay, so you said the biggest difference between 2018 versus the 2021 energy code was the exterior wall requirements or the raised heel trusses?
Yeah.
And so when I have builders that say that the height of a building may become an issue, that's only if they're using the raised heel trusses. It wouldn't be an issue for them if they were using the exterior wall.
Well, so that would be more of a zoning question related to it too. So the height limitations on a building, that's going to be fixed by the zoning code, I would imagine. But the height on it, if you're really close to that threshold and now the code's saying you have to go higher, that's you still have to go higher. But if you can't because of zoning, well, then that means there's going to be an impasse at that project for it, and you'll have to find a different way around. Is that what you're getting at?
Yes, but sorry, that's really loud. Yes, but you were saying you could, or I thought you were saying that I could use the exterior wall requirements, and then I wouldn't have to do
Correct.
the heel trusses. So
yep.
then it wouldn't be making the building go higher.
Right. So there's two paths.
There
like
is
I
an
said,
alternative.
Yes.
Okay.
Yeah. The way the code was set up again is that there is there's essentially one critical change, which is a change in either the U value path or the R value path. Now, to simplify matters, one of these touches on the U value path, one touches on the R value path. To make it simple and to help people understand, it really just comes down to, do you want to use more or less the 2018 standards that a lot of people have been used to because it was coming back from the 2015 standards as well. So it's been around in the area for a long time. And do you want to do those with this larger truss system right here on the right, which, like you were mentioning, would add height. Now, if you don't do it that way, then you could, of course, use that exterior wall. You could keep that truss just like it had been in years past, like a traditional truss system there. You'll still use a little more insulation in the attic, but you don't need to increase the vertical height of the truss. You'll, of course, have to deal with that rigid insulation on the exterior of the sheathing. Take some getting used to from what I've heard in the industry for it. But once you do it, every resource I have found from it indicates that that is not only for most houses, there's probably going to be some that are excluded from this, but for most houses will be cheaper and saves you more cost in the long term for it. It basically, think of it as reducing the amount of solar gain or heat before it gets into kind of the cavity of that wall and kind of more trapped a little bit. You're kind of reflecting sort of some of that out before it gets past the thermal envelope.
Thank you.
Mm-hmm. All right. Yeah, it's you.
Did you just call me you?
Michelle.
If I'm doing an addition and I want to use the existing furnace, how do I calculate this on my worksheet?
So one of the forms that I kind of briefly mentioned, I didn't go over in the presentation, but it's available at Washington State University's webpage is what they call a heating system sizing worksheet, I believe. And in that, you fill that out, of course, based on the parameters of your project, and it gives you an output for the size of furnace or heat pump that you would need. So if you're doing an addition, okay, and you want to use the existing system for it, not installing a new heat pump or a new furnace to heat and cool that addition, then you would have to fill out that form instead of from the perspective of just the addition. Let's say it's like a 400 square foot addition on a 1,000 square foot house. Instead of 400 square feet, you would do 1,400 because you would have to factor in what the demand on that system that's existing already, and it's already servicing that 1,000 square feet. So then you would have to use the 1,400 value for it. You would want to be as accurate as you can be, even though the existing house in this specific example would be outside of the scope of work. So we can't really govern it too much on it. You would still want to put in the amount of windows from the existing house in this form. The form walks you through what kind of insulation values are there for the walls, for the ceiling, the floor, all that stuff. You would want to be as accurate as possible for it, understanding that all that information may not be readily accessible. So do the best that you can for it to give you the best picture, I guess, or snapshot of it that's possible.
I have one more question.
All right.
If I was already in the middle of my project and it was under the 2018 code, and I now have the option to do the gas, will the alternative means of method work for the 2018 code as well?
So as we see it right now, if you're under the 2018 code, the law still is current. So how it applies, typically when a project starts, whatever building code is current at that moment is what you would need to conform to throughout the entirety of your project. However, you also still have to comply with current law for it. And so this is being a current law, you have just as much claim for it, but how the specifics of that integrate with the 2018 versus the 2021 energy code might be a little more unique and require a case-by-case basis on it. So that would be, if that specific example were to come up, we would probably want you to consult with either the permit center and or plans examiner to kind of coordinate what solution would be best in that moment. With this, the solution I went over briefly here of that 1.5 credits is more directly related to the 2021. It may be simple enough to kind of apply that to the 2018, but we can't give a blanket approval necessarily for the previous code for it. Any other questions? All right.
All right, thank you so much for attending today. Thank you so much for attending today's session. Our next session is presented by William Oglesby, and the topic is Dog and Cat Preventative Care and Licensing. This is going to be scheduled for the third Thursday of March, so March 20th at 11 a.m., and we hope to see you there. You did great. You did really, really good.
Yeah, it's